See, you guys, I think very well know the network topology architecture, how it will be happen. Like, see, these all are access layer switches, access switches, and this access switches connected to host. It might be server, it might be end user, it might be anything. It might be access point also, AP. Access point, it might be access point in the sense Wi-Fi device, and it may be your end user, it might be your server. These all are, will take here server, it might be server. Okay, it might be your again server. This is the DNS server. It want the TCP something, HTTP server, any application server. It might be, you can assume anything. It's HTTP server. These all are host end users. Now this end user connected to distribution layer. It's maybe L3 switch. It may be L2 switch. You can assume anything. It might be for 4500 switch. You can assume like 4500 series switch. It might be 2960 access switches are there. These are L2 switches, and these are connected to our core device, core switch. This core switch, and core switch connected to our any firewall, ASA or Palo Alto, any firewall. Okay, this core device is connected to our end edge router, customer edge, C edge, customer edge device. This is a firewall, and this firewall is connected to a device, edge router. In this edge router, we'll use EBGP protocol. Apart from that, we'll use MPLS. If MPLS is running, if legacy or traditional topology will use as a MPLS. Otherwise, this router only, this device only. If you can assume like C edge router, C edge in the sense our SD-WAN device, and V edge. These all are V edge. We having edge devices like C edge having series of router like 4451, 4431, 4461, this kind of series. And edge routers are like 100 series of router, 100 number, 100 series, otherwise 500, this kind of edge devices we have, and 1000 series, 1K. That is very depending on model. Okay, if 100 series means features are very less. If it is higher version means it prices also high, and they're having multiple features. Like here also we having 4431 series router. The price might be it's 13 lakhs, and there we having like 10 gig port, 10 gig port, and this 10 gig port connected to SFP. Again, in real time will facing the issues in physical issues, in the sense SFP only. SFP is a one kind of this kind of how many guys you know the USB in your laptop? It will be connected to file sharing, will you with the help of USB will sharing the files. Likewise, we having a one kind of USB device. It's SFP in the sense USB kind of device, simple form factor something. Okay, this kind of device, if there will connect to the one RJ45 connectivity, it will be RJ45. Apart from that, there in this there also, in SFP also we have a simple types of devices. One is RJ45, other one is optical fiber connectivity. Will connect likewise. Will connect in this. You can assume this is your device, one of your edge edge device. This edge device having multiple ports. These are all are ports. These all are ports. There will connect with the help of SFP only. This SFP device to one port, you should have to connect one other device, right? In this SFP device, in SFP, it's kind of one kind of uh, it's like a device only, small device. I'll show you this kind of device only. See, you can screen is visible. Wait,
Yes, Ali.
wait. Maybe it will be. Once I'll remove this means I won't get. What I'll do, minimize these things. I'm not able to minimize this.
It's all right. We can see that.
If I minimize this thing, then you can easily these things. Otherwise, can please guys, this kind of device. It is visible.
Yes, sir.
Okay.
Yeah.
This kind of SFP will plug in into that edge device, and these are the uh, optical fiber cable connectivities. Will face the issues like this devices always creating the problem issues in whenever you are getting tickets. Some router port is not coming up so long. Just you should have to check this kind of SFP device also. Understood? These are physical connectivity. Where will plug in it means in switch we have a in switches. Likewise in switches, you can check here how this is a fiber connectivity cable, and this is one is the SFP device module. Yes, you can check here. This above one is the SFP device. Got it? No, this kind of connectivity, this SFP having creating the problem sometimes in real time. Guys, any doubt? Guys, if you have any queries up to here, Ravali, Saisri, Yamuna, Ajay, Abhinav,
Yeah, all good.
all good? Fine. These all are SFP. Now remove. And now the device is connected to firewall. We will know very well in this firewall. Sometime we have a one V wire option also. It can be act as like it is like a L1 device. No need to configure L1 device. No need to give a IP address, MAC banding. Nothing is required. Only for monitoring purpose. This end user, which kind of application he is using, will check with the help of vWire. Once you configure vWire mode, there in this firewall, no need to configure it. We have a different types of mode in firewall connectivity, like L2 mode, L3 mode, vWire, tap mode, this kind of. If you guys know this kind of modes, then firewall part sufficient. vWire in the sense, it's acting as like nothing to it's physically connected, but no one knows. So no one don't know there is a one firewall is there. Apart from that, we have a tap mode, and this tab mode, PAB, tap mode, PAB, tap something TAB or TAB tab mode. In this tab mode, just you will monitor the device. You can give the IP address and all. There, just you will monitor what is doing, which policies we are created, and what is the functionality is there. Don't worry, we have a session for the firewall also. I'll show you the firewall connectivity, and I'll show you the every mode also. And we have a L2 mode. With the help of L2 policies will create whichever with MAC policies. It means this system having one unique MAC address. If he want to access some server, it is in different location. Is that server is in different location? That server is in different location. There we having a one application like FB. You can assume like Facebook application, FB application. He want to access the FB. In that FB also we can create. He don't want to access. He will not access the chat file. Chat only chat he cannot access. Videos he cannot access. Only he will check our website, whichever our application we advertised in that, he can check the notifications things only. Those things only will allow. Apart from that, he cannot do anything. That kind of access we can create with the help of policies. In that policies, L2 policy is there, L3 policy is there. L3 policy in the sense again with the help of IP addresses. IP addresses we can create the policies in this firewall. We can monitor everything. Apart from that, we have a core device, core layer. This one is a distribution layer, and apart from that, we have a access layer. Okay, will coming from now access layer. In this access layer, we'll create the VLANs for end users. If we have a multiple branches, if we have a multiple departments at a in one branch, one organization, one building, we have a different floors, and likewise different floor, first floor, second floor, third floor, fourth floor. Likewise, we create multiple VLANs based on floors, first floor, second floor, and we'll create the trunk here. In between trunk, we'll apply the trunk link. It will be carry the multiple VLAN information. Then we have a this 4500 distribution layer switch, and apart from that, we have a core switch. In between, we use OSPF, EIGRP, IBGP, RIP protocols for advertising. Whichever if we have in this LAN side, these all are one kind of LAN, local area network. In this local area network, we have 100 VLANs, and this 100 VLANs having 100 prefixes, 100 prefixes in the 100 networks, 100 networks. In this 100 networks, each one having multiple users, in the sense in one network we have a /24 value, /24 CADR value, /24 we having 253 end users. This kind of users will advertise in this all the prefixes in OSPF to connect, to reach to different location, we'll creating here routing protocols, here trunking protocol or ACLs, and access layer will advertise the VLANs. This is a 3-tier architecture up to here, and we have a for advertising here also will advertise like we'll use EBGP or IBGP based on our topology. Mostly we'll use IBGP. Up to here, any doubts? This is our architecture of 3-tier. If you got a ticket, in service now, Okay, in your organization, you are in the L2 position. One person is assigned to you. He is not accessing the application. He is not able to reach his application. Apart from that, he is getting APIPA IP address. APIPA IP address. Then that end user getting APIPA IP address. This kind of tickets you will get, and he's not accessing some like here one more application is there like some X Y Z application is there xyz.com is they inside organization they're using application one of the application that is xyz application. He's not accessing this application. Guys, now you tell me how you will troubleshoot this ticket in real time. How you will troubleshoot this ticket, this kind of ticket if you got means how you will check, how you will troubleshoot this ticket. I want to listen from your side first. Randomly give the answer. Okay, just now he's sitting here. Okay, the application is different location, the application is this location. Okay, I will draw again, then only you will understand. This is access switch AC, access switch. One access switch is there, access layer switch, and this access layer switch having multiple VLANs, multiple host, and take as a one VLAN, that is VLAN 10. Listen properly, guys. VLAN 10. This user having is in VLAN 10. This is having connected to one distribution switch. This is the access layer, access switch, access port, and this one is the trunk port. This is the distribution switch, and L3 you can assume. And this distribution switch is connected to one core switch, 9300 series core switch, and 93 core switch connected to one firewall, and this firewall having, here you are using SD-WAN technology. Okay, here you are using SD-WAN technology. This also C edge device, Cisco edge device. This edge device is a uh, 4431 series router. This one. Okay, you can assume this one is a your R1 router. Edge device, customer edge device, and this customer edge device having two ISPs, and this device is connected to ISP. Again, these devices is connected to your data center. Sorry, this in this data center you have like two devices for redundancy purpose. Here on in this branch only one device you can assume. Here no redundancy router is there, but in your data center you have a redundancy part. This is the one edge device, and this one is other edge device. Again, this edge device having firewall 1 and firewall 2, and this firewall are connected to one core device, core switch. This is your data center. This ISP 1 and ISP 2. This one is the R1, again R2, and this is a firewall 1, redundancy firewalls. Redundancy firewalls. If one firewall is an active state, another other firewall is standby state. If both are at a time active state means you cannot access your servers also. These are core devices again. These core devices having again distribution layer switches. These distribution layer switches likewise redundancy part connected likewise, and they are having multiple access switches like connected access switches, multiple access switches you have in data center, multiple access switches, they are connected to likewise, because in data center you have a large app which fixes. Okay, this access switches is connected to one server, is a end user. Okay, server, in this server only you have x y z dot com application. This end user having IP address like you can assume like 10 dot 1 dot 1 dot 1, and sorry, you can assume like 10. Because of we have a gateway here 10 dot, not here, this gateway is here 10 dot 1 dot 1 dot 1 gateway, and this gateway advertised some sorry, because we'll advertise here a different routing protocols. LAN side will advertise here 10 dot 2 dot something 1 and 2, and this one is 1, and here is the our gateway 1 dot 1, because here only will advertising our trunking. Now you tell me, this application is not accessing here, and this server having one IP address like 1 dot 1 dot 1 dot 1. This DNS we are using here, DNS domain name server. This end user not able to accessing this 1 dot 1 dot 1. If he's access 1 dot 1 dot 1, then only he can access website. Now you tell me guys, how you will troubleshoot. How you will troubleshoot? Whatever answer, no issue. Just give you whatever you know. Just give that kind of answer. I'm agree with you. If you are giving right or wrong, no issue. Whatever. Everyone should have to give some basic knowledge. Whatever you have, just give the those answer only. I'll accept. Tell me. Start. Who will start? It's kind of scenario question.
Like I may disable Ethernet or restart DHCP again.
Okay, Shaisri, what you will do? From starting onwards, you will start from here, from how you will troubleshoot. From end user, you should have to start from here. I'll move to the customer monitor, then I'll check the IP config detail, which IP he's getting IP or not. Likewise, you should have to like IP config. Likewise, this is a first step. What is getting IP address, and apart from that default gateway, which default gateway is getting, I'll ping that gateway likewise. Okay, step by step. Start. Size you can continue, no issue, whatever.
Mm.
Ravali, Yamuna, Abhinav, Ajay, anyone?
Yeah, first we will check the IP configuration in the device and later we'll check the access port and the trunk port in the layer 3 switch and also we'll see whether the default gateway connection is done in the core switch or not and we'll check the firewall connection whether it is enabled properly or not. And in the switch, we'll see whether the like it is reaching up to there or not, whether if any signals is sending or not. Till that point I understood, but later I didn't get.
Okay, good. Good. Ajay, you will add on something? Whatever Yamuna explained.
And
Anyone? Ravali,
Ali, I have
Ajay.
a doubt.
Yes,
In
tell me.
the core device, what address will set up? Like in the layer 3 switch, we'll set up the access port default gateway. But in the core one, what IP address will we give based on what?
/30, whichever subnet is different, /30 will assign here IP addresses, because in this /30 we have a valid host only 4. Okay. Why we'll assign this /30 means we don't want to wastage IP addresses. Of course we'll assign up to here all are private IP addresses only. But will whichever we are giving will advertise those prefixes, this prefix, every prefix in IGP protocol, because whatever the IGP protocol is there, it will be carry and it will be sent to different location with the help of only whichever OSPF you. Okay, OSPF. I'll show you now. In lab, we'll discuss those things. But /30, because of we don't want to waste our IP address. Variable length subnet mask, VLSM. Clear? Good. Ajay or Ravali, you are telling something.
Yeah, we'll do the same, Alim. Like, first thing, we configure the PC like what I mean. We'll check everything like it is configured with IP address, and it is connected to the internet properly, and then once if it is okay, then we will go to the access layer, and then we configure the access layer, like we see everything is clear, and then we go to the trunk port, and then yeah, and then if it is clear there, like we go to the I mean we will check the routing parts is clear, or if it is routing, the communication is routing properly for the other networks or not. We'll check that, and then um, we check the internet stability. Internet stability with the router. Yeah,
Okay.
and
Fine.
we'll try to ping from if it is not pinging to the other network, we'll try to ping internally. So if it is not pinging to the other network, we definitely know that it is the internet issue. So we configure like the router level configurations.
Okay, good.
Yeah.
Fine. Abhinav?
Yes, Salim.
Go ahead. Something, whichever you have idea, give the.
No,
I
I'm
will
just
this one.
learning the I'm just learning the basics right now. So
No
I'm
issue,
not in
no
a
issue.
position.
See, no issue. You are the basic only, but basic, whatever you know. If you are not getting, you are not accessing this server. Okay, you are in different location. That server is in data center is in different location. Basic concept, whatever you know, just give that idea out.
Uh, Probably if there's uh, everything is connected by the IP address, so we should go by the IP address itself.
Okay, fine. Ajay,
So
yeah, add on something.
basically, like the VLAN, first we need to go to the router and the IP address verification, whether it's in the right path or not. And when it comes to the trunking port, we need to test the connectivity between that. If it's like a net to check the network on the internet connection. And later on for the core switch, at the same time we need to check the connectivity of the core switch, whether the packets are passing through that or not. And at the you need to check the trace route to the device, like using the OSPF and all the routing technique. And at the firewall, we need to check the response time and determine the firewall blocks the traffic or it allows the traffic
Okay,
from there. That's coming from the R1 router.
okay, fine. Good. These all are comes under access switches, access layer. Access layer in the sense will configure here as a access. It will be carry the only one VLAN information. So that is the reason we have a only one VLAN. Like if we have a different VLAN, if we have a different VLAN, this port as well all are like single port. That is the reason I'll configure it like switch port mode access. Then these all are the trunk mode. Then I'll check first this PC which IP it is getting with the help of IP config detail. Once there I'll get the my gateway also. Then I'll ping that gateway. I'm getting here 192.168.1.1. This is my gateway. I'll ping that gateway. If ping 192.168.1.1, then if it is pinging in the sense the gateway is reachable, then after then I'll move to the core layer, core to distribution. There I'll configure as a OSPF. The neighborship both are in upstate or not. Then I'll check the core, whichever I'll log in core device. There I'll check whichever our prefix is there 10.1.1.1 10. The root is available or not. I'll check in there. If it is there, then I'll ping from core router. Then it is pingable, then no issue. Then I'll move to the firewall. Any policy I have created here, like for that particular particular prefix, if which kind of policy means the whichever we are having application or server IP address, based on that IP address or host name, I have created any policies like deny or permit. I'll check those policy in firewall. If it is there, if it is deny, then I'll permit based on our team manager, whichever our manager told. Likewise, I'll discuss with manager sometime. I'll do that, and once that is deny or permit, if it is allowing, then only I can access that device. Maybe the issues is those are issues in available in like firewall only. Okay, if firewall there is, after then also if deny state is there, then I'll permit. After then also it is not pingable, then I'll move to the router. That is, we have a C edge in the sense it is a SD-WAN device. Then I'll check there whichever templates or policies are in this SD-WAN technology. Also we have like policies. I'll check feature policy or device template feature policy, sorry, feature template and device template. If it is any problem on that, I'll check those things. Those prefixes whichever advertised, those prefixes I am getting in this router or not, I'll check those things. Apart from that, here we have localized policy for the single brand. We have a centralized policy for all of the fabric. It will be applied. Then I'll check those things also. Localized policy and future localized and centralized policies. Where I'll check, we have a vManage dashboard. There I'll check. Then I'll move to the ISP also. If any ISP packet drops is there, then I'll assign the ticket to ISP guys. Likewise, I'll troubleshoot whichever ticket is there. Guys.
Okay.
Likewise, we should have to explain if anyone asks you in interviews. We'll do.
Could you once again tell for the CH one?
Yeah.
The other one, yeah.
Yeah, C-Edge. See, actually, C-Edge is nothing but to SD-WAN device. In SD-WAN device, we have a like future templates and device templates. In this future templates, we'll create for OSPF, all are the features, OSPF, or NTP, Network Time Protocol. And apart from that, if we have a different protocols like whichever VLAN, something VLAN we won't configure, VRRP, everything is available in this feature template. This all future templates will combine into apply this device template. For this device is like for particular device, the series is like device 4431. 4431 will create here one 4431 device template. This device template will push to this edge router. I'll check any future templates are missing or device templates are missing, and I'll log in CLI mode in this router. I'll check whichever routing prefixes are there. Those are we having underlay and overlay. Underlay in the sense whichever getting from ISP, those are underlay. Whichever we are advertising prefixes with the help of OMP, with the help of OMP protocol, those all are coming under overlay management, overlay prefixes. Overlay, underlay concept and overlay. Overlay in the sense it will be created tunnel. Underlay in the sense ISP. This is a not secure, right? So that is the reason we'll advertise our whichever confidential information is there, confidential prefixes is there, we'll advertise those prefixes overlay. Tunnel with the help of VPN. Tunnel, it's kind of VPN tunnel. We'll call like DM VPN tunnel. We have a DM VPN tunnel apart from that IPsec tunnel. IPsec tunnel. Likewise, the control plane will be control connectivity. Control we have like control plane and data plane. Data plane in the sense it will be carry the user information. Control plane in the sense it will be carry the routing protocol information. Don't worry, we have a brief discussion about those things. But for time being, In this SD-WAN technology, we have feature template, device template, and we have localized policy and centralized policy. Localized policy, it will be applied only for particular branch, and centralized policy, it will be applied. Centrally in the sense, all fabric. Clear?
Yes, clear.
Yeah, this is the SD-WAN device. Okay, we are using SD-WAN technology here only, not inside. If we have another technology, SD access. Sorry, software defined access layer. Access layer in the sense, again, our access switches. If you have multiple access switches, you can monitor with the help of vManage. In that also, we have a DNAC dashboard. With the help of, you can monitor. In this vManage, you can access. And apart from that, we have a ACI. We'll use ACI. This ACI technology is for the data center location. This SD-WAN is that SD-WAN will use. We have a 3 type of technologies: SD-WAN, SD access, and ACI. ACI in the sense will configure in between data center. SD access will configure our LAN side only, but SD-WAN will configure at two different locations, 2 different branches. This is the SD-WAN technology. Just now I'm giving a brief introduction only. I'll explain in depth later on sessions. Okay, guys.
Okay, sir.
This is a 3-tier architecture. There we have a firewall. Up to here, 3-tier architecture will configure here. This is a firewall. Apart from that, we have a core customer edge router. Customer edge connected to one edge, provider edge router. This provider edge router, in between, will use MPLS technology, multi-protocol label switching. Where we'll use MPLS? Customer edge to provider edge router. Provider edge router, it means our Jio, our Airtel, our British Telecom, okay, and AT&T, British Telecom. These kind of ISPs will, whichever device is having, those devices will connect it to the provider edge to customer edge. Guys, any doubts? Fine.
Yeah.
Okay, evening what we'll do, I will show you some basic configurations at evening session. Okay. Now I think
Okay.
1 hour finish it, right? In the evening we'll discuss something else. Fine.
Bye.
Bye. Bye everyone.